So today we'll try to solve some numerical on Reynold number. Okay. So this is related to your fluid flow, fluid mechanics. Okay. So we have discussed like what is a steady flow, what is a streamline flow, and what is a turbulent flow. Okay. So streamline flow is something where if you take at any point at any location in the pipe, the velocity at any point will at any
Constant.
location will remain constant with respect to time. Okay, so there is no mix up of flow. Okay, so there is some thumb rule like how we will define the how we will define the whether the flow is streamline or turbulent. Okay, so that is defined by something called a Reynolds number. Okay, so that Reynolds number has a formula. Okay, so that Reynolds number we otherwise write is at Re. Okay, which is equal to rho V D by nu. Okay, so what is this rho? Is density of fluid. Okay, it can be any fluid. It can be water, it can be oil or whatever. Okay, so this is the density of fluid. V is the velocity of fluid. Velocity of fluid. Okay, and D is the diameter of the pipe of the pipe. And mu is your called coefficient of viscosity. Coefficient of viscosity. Okay. So there is a thumb rule, like there is a rule, if the Reynolds number is in this range, then this is laminar, this is turbulent and all. Okay, so the thumb rule is like this, which if Re is less than 1000, the if Re is less than 1000, the flow is steady. Okay, flow is steady. Okay, steady. And otherwise it is called laminar also.
Yeah.
And if it is in between 1000 to 2000, let us say 1000 to 2000, Re less than 2000. If it is in between 1000 to 2000, then the flow becomes unsteady. So this is this is transition from steady to unsteady.
Unsteady.
Okay, so this range is transition from steady to unsteady. Okay, if you get the Reynolds number between this, and if your Reynolds number is greater than 2000, it's a turbulent or unsteady flow. Or unsteady flow. Clear? So I can show my pipe to be like this. Okay. So let us say this is my pipe. Okay. So this is inlet and this is outlet. So let us say the diameter of my pipe, this diameter is D. Okay. And let the velocity at any point, let it be V. Okay. So velocity, your diameter, we
Density
can
and
write it as small d. Normally we will write small d or capital D, whichever you want to write. Okay. So one thing you have to remember: all these unit we have to be consistent unit, SI unit.
SI unit.
Okay. So we have to convert things into SI unit to find out. Okay. And this nu, what it is? So this is coefficient of viscosity. So we know like the formula for viscosity. Okay, so it is like
What?
F by A is equal to nu dV by dx,
Yeah.
right? So this is the formula. So this side it is pressure and this side it is like say strain rate or
Yeah.
whatever we say. So in shear stress calculation or rigidity modulus, so it was unitless. It was strain here, it was stress
Here
here.
it is 10, right?
Here it is strain rate. Okay. So your this is your coefficient of viscosity, which is equal to F by A divided by dV by dx. And okay. So and this F by A will have a unit of Pascal, right?
Yeah.
And this is strain rate, so that's why
Meter.
yeah, so it will be 1 by so dV. Okay, so meter per second divided by meter, right? Right.
Yeah, me.
So it will become meter cancels. So
1 by x.
so Pascal into second it will become, right?
Yeah.
Cancels, and so Pascal into second, that is its unit. Okay. So you take a picture of this. So this is, you take a picture, we'll do a numerical. Uh, yeah. So the question given is like this: What will be nature of flow of water from a circular tap? Okay. So let us say I have a circular tap. Okay. So I have a tap. Okay. So water is flowing out of this. Okay. I have a circular tap. Uh, what will be nature of flow of water from a circular tap? When it flows, when its flow rate increased from 0.18 liter per minute to 0.48 liter per minute. Okay.
Increases.
So my flow rate I can write it as Q1. Okay, let us say Q1 or quantity, and Q1 and Q2. So initially the Q1 is equal to 0.18 liter per minute. 0.18 liter per minute initially. Okay. Now it is increased to 0.48 liter per minute. Okay. Then the radius of the tap is 0.5 cm. Okay. So this is my radius of the tap. Okay. So the radius of the tap is 0.5 cm. So this is the R. So R is 0.5 centimeter.
Yeah.
Okay. And the viscosity is 10 to the power minus 3 Pascal second. So viscosity is nothing but your coefficient of viscosity, which is equal to 10 to the power minus 3 Pascal second. 10 to the power minus 3 Pascal second. Okay.
Okay.
So that is the unit of velocity. So let me find out the RE1. Okay. So when the flow rate
Is
depends on
0.18.
the Reynolds number depends on the flow rate. Okay.
Yeah.
So my RE1 is equal to, like say, rho V d by nu. Okay. So here d nu everything will remain constant. Viscosity is the property.
Only the Q
Density is a property,
of the fluid.
and
D is
velocity can vary, and d is constant. It is a geometry. So it will be rho v1 d by nu. Right. So I know. Yeah. So I know density also. I know is the density of water. Okay. So how I'll find now? I'll try to find out the Reynold number. Okay.
Yeah.
So 1 is equal to, so I know how much is my density.
1000
Density of water is 1000 kg per meter cube. So I have to put SI unit only.
Yeah.
So density is 1000 kg per meter cube. Then I have to find out my V1. Okay. So V1 is equal to, like, I know Q, quantity of water flow, the flow rate is
0.18.
equal to area into velocity.
Yeah.
Area into A into V1. Okay, because area, AV is your flow rate. Area into velocity is your flow rate in equation of continuity of studies.
Yeah.
A1 V1 is equal to A2 V2. So now my V1 is equal to Q1 by A. Right? So now this Q1 is equal to 0.18 liter per minute. Okay. So 1 liter is equal to 1000 cc, right?
Yeah.
You know 1 liter is equal to 1000 cc,
Yeah.
centimeter cube.
Yes.
Okay. So this I have to convert into meter cube. Okay. So 1000 cm cube, right? Cm cube, right?
Yeah.
This is cc means centimeter cube. So 1000 cm cube. So 1000. Then this cm I have to write it as 10 to the minus 2 meter. Okay. 10 to the minus 2 to the power 3 meter cube.
Yeah.
Right. So this becomes 10 to the power 3 into 10 to the power minus 6 meter cube.
Yeah.
Right. So this becomes 10 to the minus 3 meter cube.
Yeah.
So this is my 1 liter is equal to 10 to the minus 3 meter cube. So this becomes 0.18 into 10 to the minus 3. This is this many liter per minute. So that means 60 second. So this becomes
180 by 60.
This becomes a meter cube per second, right?
Yeah.
So
180 by 60 it will be
180. Why 180?
10 power minus 3, so it will come to denominator.
Okay.
Then
Okay,
0.18 divided by
okay.
1000.
So so Q1 I am writing. So Q1 is equal to 0.18 divided by 10 to the power 3, right?
Yeah.
Into 60. Okay, so then my area of cross section. Okay, so my diameter, now my radius is 0.5 cm. That means diameter is equal to 1 centimeter. Okay, 1 centimeter is nothing but 10 to the minus 2
meter.
10 to the minus 2 meter. Okay, so this is my radius. Okay, so my area is pi r square. So pi, then okay. So this is diameter. Okay, so it will become pi by 4
D square.
d square. Okay, d square. So this become 10 to the minus 4 meter
By
square.
4.
Meter square.
Yeah.
So one is meter cube per second. 1 unit is meter cube per second. Okay, and the other unit is meter square. Right? Then it becomes meter per second. That's what we want.
Yeah.
Right?
Per
So
velocity.
by solving all this, we yeah. So my RE1 becomes okay. So let me see. I'll write it. My rho was density. So which is equal to 10 to the power 3 kg per meter cube. Okay.
Yeah.
So 10 to the power 3 kg per meter cube rho.
Into velocity.
Okay. Then into velocity. So velocity value is this. Okay. So your velocity value is 0.18, 0.18 okay, and then divided by 0.18 divided by 10 to power 3 into 60 into pi by 4 into 10 to power minus 4. So this becomes your velocity, right? Then your diameter is 10 to power 2 meter, 10 to power minus 2 meter, right? Which is 1 centimeter, which is 10 to power minus 2 meter, right? So you have replaced your rho V1 D and your new it is already in SI unit, Pascal already there. So that you have to divide it by 10 to power minus 3. Okay. So after solving this complete term, so this if you solve, if you do solve it, then you will find the first Reynold number. So it will be a unitless number.
Yeah.
Okay. So this you will find out to be 382.16. So your this value is equal to 382.16. So your RE1 is equal to 382.16. Okay. Then next this value.
Same thing for
So the flow rate has increased from 0.18 to 0.48. So replacing all this, you can find the second Reynold number. So RE2, if you solve, you will find it out to be 1019.66. So because of the increase in flow rate, okay, your Reynold number has increased from 382 to 1019. So earlier we have told that when it exceeds 1000, that then it has entered into the transition flow. So you have various options like so the option is the first option is it remains turbulent flow. It is not correct. It is not turbulent at all.
No.
So when it will be beyond 2000, it will become turbulent. Okay. So it has transitioning from steady flow to unsteady flow. That is correct because initially it was 382, which is less than 1000. So it has increased from 382 to 1019. So it is transitioning from steady to unsteady flow. Okay. So then another option is unsteady to steady, which is not correct because you are increasing the flow rate, it will become steady to unsteady. Okay. And then the third option is remain steady flow.
No.
If it is less than 1000, we would have told that it has remained steady flow. But it has crossed 1000, that's why it has changed from steady to unsteady flow. Okay. So the option that it has the option that it is changing from steady to unsteady is correct. Okay. So with this one numerical, you can understand what is flow rate, how to find out velocity from flow rate. If the flow rate is in liter per minute, how you will get the velocity in meter per second, how to deal with consistency of unit, the coefficient of viscosity, the formula is Pascal per second.
An equation of continuity.
Huh?
We used equation.
Equation of continuity Q is equal to A V1 or A1 V1. So the basic understanding is like this. Suppose how you increase the flow rate. You open the tap. Okay, your flow will increase. So when your tap is almost closed, it was kind of 0.18. You open the tap, it has become 0.48. So when you open the tap, you might have observed the water will not be turbulent. Water coming out will not be streamline or steady in nature. It will become turbulent. Okay. So why? Because the velocity will increase.
Increase.
When the velocity increases beyond a certain value, the
Become
flow
unsteady
becomes
flow.
unsteady and turbulent. Okay. So so now you understand like
Yeah.
how to find out Reynolds number. So first formula you have to remember
Rho
Reynolds
VD
number
by
is equal to rho V D by nu. So rho is the density of fluid, V is the velocity of fluid flow in the pipe,
D is
D is
diameter.
the diameter of the pipe, and nu is the coefficient of
Viscosity.
viscosity. Okay. So that coefficient of viscosity has a unit Pascal per second. Okay.
Okay.
So now, okay. So you take a picture of this. Okay.
Done.
You have taken. Okay.
Done.
Yeah. And so there is some other question that has come. A flow of a liquid is streamlined if the Reynolds number is between 2000 to 3000, less than 1000, between 4000 to 5000, greater than 1000.
Less than.
So less than 1000 is the correct answer. Okay. The so less than 1000 is streamline. So between 1000 to 2000 it is becoming unsteady. Beyond 2000 it or beyond
Turbulent.
2000 beyond 4000 it is all turbulent. Okay.
Yeah.
And so that is the answer. So that is a very simple one, direct question. And they will give the number. Okay, this is the Reynolds number.
We'll
Tell
give
whether
range
it is
and
steady or whether it is transitioning from steady. So just remember, less than 1000 steady, 1000 to 2000 transitioning from steady to
Unsteady.
unsteady. Beyond 2000 it is turbulent.
Turbulent. Okay.
Okay, so there is another thing. So water is flowing through a very narrow tube. Okay, the velocity of water below which the flow remains streamline is known as. So the options are relative velocity, terminal velocity, critical velocity, particle velocity. The answer is critical velocity. Okay. So because it is not relative velocity.
Yeah, that right.
And terminal velocity, what we have studied
Oh,
is
yeah.
when you are suppose in a
Dropping
water you
something
are
or
dropping
something.
some thing after after traveling some distance, it will attain a velocity,
Constant.
constant velocity
That
beyond
is
which there
terminal.
won't be any acceleration
Listen.
because there on the force, the buoyancy force, which is acting
Balances
upward.
that and keeps a constant velocity.
Yeah, so the viscous force, the buoyancy force, those who are acting upward, is balancing the weight.
Yeah.
So when it is balanced, it attains terminal velocity. Okay, so that is terminal velocity. So here at critical velocity, the flow changes from laminar to turbulent. Okay, remains streamline. So velocity below which the flow remains streamline is called critical velocity. Okay. Okay. So we'll do in our next session we'll do few numerical on terminal velocity. Okay. Okay. Thank you.